Hello, everyone. Happy Earth Day, and welcome to the Recycling Management and Robotics session. Um, this session is all about humans creating an enormous amount of waste every day. This is across industrial, commercial, residential streams. And this session is very important because this waste is not managed well at all. It poisons the soil, it poisons the oceans and animals, air, of course, degrades the health of humans as well. And even though there's some push for recycling in many places on Earth, the efforts are falling short. They do not scale. They are not bringing us to the desired level of the throughput and accuracy. And robotics can indeed help us get to the levels that we want. Robotics has a high potential to achieve these recycling systems, recycling or management that we are really looking forward to. And we will discuss this in this session. But at the same time, we should also recognize that recycling should be the last resort indeed, because reducing the waste that we are creating, reusing some of the products that we have been using should be an integral part of waste management. So could robots be also useful for that? So our panel is a wonderful collection of expertise to discuss all these issues. So we will now have a quick round of introductions. Let me start with myself. I am the moderator of this session. I am one of the co-organizers of the Climate Robotics Summit. I am from Worcester Polytechnic Institute in Massachusetts, from the Robotics Engineering Department. Our lab is Manipulation and Environmental Robotics Lab. So two of the projects that is relevant to this session is we are developing waste recycling robots, oftentimes focusing on the residential waste. We are creating data sets. Actually, the zero waste data set has been the only open source waste data sets so far that is actually acquired from a real waste sorting facility. We are also focusing on auto labeling of recycling data so that we can create these kind of AI models that could be useful for robots. And we are doing it with a human-robot partnership framework, for example. And we are and that human-robot partnership is about learning from humans' actions and also transferring these to the AI models. And finally, we do some work on metal scrap recycling, specifically ship-breaking robots, which is a sustainable way of recovering the decommissioned ship metals, if it is, of course, done in an environment-friendly way. But let me stop here, and our panelists, we will go for a relatively short instructions. We will introductions, sorry, and we will start with Manuel.
Hello to everybody. It's a pleasure to be here. I am a researcher at the Italian Institute of Technologies. My background is in developing of robotics technologies for manipulation and handling of interaction with the world. Today, I am the coordinator of a big European project. FlexCycle is the name, and the scope of the project is find ways how to integrate AI technologies and robotics to handle and manage waste that are deformable. We work especially in three use cases: clothes, cables, and dismantling of fuel cells.
Thank you so much, Manuel. Alireza, could you go next?
Hello, everyone. Thank you, Beck, for inviting me for this interesting summit call. I'm Alireza Rastegarpanah. I'm assistant professor in robotics and AI from Master University in the UK. And my background is all about developing AI-powered robotics technologies for robotizing the process of testing, disassembly, and sorting EV batteries. The methods that I'm developing are agnostic in the way that can be generalized for various types of complex products. And the aim is to reuse or recycling such critical materials. At the moment, I'm the co-PI of large EU-funded projects called Rebellion that we are trying actually to integrate digital passports with these kind of AI-powered technologies in order to basically address safety challenges and also address the issues related to these waste handling and waste management. Thank you.
Thank you very much. Let's go with Ellen next.
Hi. I'm a professor of robot ethics in the Bristol Robotics Lab. In fact, one of the co-founders of the Bristol Robotics Lab, which is pretty much the largest general purpose robotics lab in Europe, or one of two or three large labs in Europe. My background, I was an entrepreneur, and the early part of my career was spent building safety critical communication systems, particularly for public safety. In other words, police, fire, ambulance, airports, railways, and stuff like that. And that really, in a sense, got me into ethics, because ethics is really safety plus plus. So that's me.
Thank you so much, Ellen. Helen.
Hi everyone, I'm Helen McGloin, and I really work at the intersection of robotics, sustainability and the circular economy, with a particular interest on e-waste, so electronic waste, and the reason for that mainly is to look at what happens to robots at the end of their life. So my research usually starts with a question: if we're building something problem solving with robots, do we think enough about their life cycle impact, and are we doing that in the design phase? I tend to use a lot of data around global waste management of electronics to see what we can learn from, and taking applications of reuse, repurposing, and circular economy principles and applying them into robotics. My background is from the aerospace industry. I worked in manufacturing research, and I'm very aware of both the conflicts and the opportunities that come with applying circular economy principles to the robotics industry. But I feel that as we design and as we develop and deliver a more numerous and broader application fleet of robots into the world, we really need to ask the questions of ourselves of what the impacts of those systems are, often challenging the question, is recycling the right solution?
Absolutely. Thank you so much, Helen. So as it is apparent from the expertise of this panel, we can really have a very comprehensive view of the recycling and generally waste management industry, even though it is actually quite broad. But I would like to actually start with Helen. So, Helen, I was checking the World Bank reports. When I checked them in like maybe close to 10 years ago, what they were saying is that in 2030, our waste production will increase to 2.59 billion ton waste per year, and that was an increase from 2 billion tons. So from 2 billion tons to 2.59 billion tons in 2030. That's what their projection was. It is now 2022. We have 2.56 billion tons already. So their projection was quite naive. And this is the overall waste management. And I know that you are particularly focusing on the e-waste side of these. How does the e-waste management is going globally, or this generation is going globally?
Yeah, I think that e-waste is an interesting topic because we know that those materials are often very valuable to us. And it's a kind of we need to understand both the scale of issue and responsibility. And I do believe if we look at e-waste, we can apply that to wider levels of recycling as well. But my experience is with e-waste. So the scale is huge. We're talking about, in 2019, 54 million metric tons of e-waste being produced globally. But more shockingly than that is the recycling rates of that. So formally managed recycling of e-waste was only at 17%. And you have to wonder, what are we doing with the rest of it? Well, a lot of the management is around putting it into landfill. There is obviously the storage aspect of it. Or sending it into unregulated spaces as well. Even where we maybe consider that we're good at recycling, so within the EU, the average is only 45% of electronic waste is being properly recycled. So it's fair to say that maybe that isn't the right method. So as well as talking about scale, we have to understand how people are reacting to it. We all quite like to take a route of least friction when it comes to managing our waste, and e-waste is where that really happens. So whether that's at home and you've got a mobile phone you don't want and you shove it in a drawer and you leave it there for a very long period of time, or you just put it in the bin because you can't recycle it, or you're a business that manages recycling and it's easier to send it to another country where you're not monitoring it, that's when we get hazardous waste going into landfill, ending up in our waterways. We're losing precious materials, but we're also harming our environment. So e-waste management decisions, really we need to start looking upstream, I think, and apply those circular economy principles to really say that we're not just talking about a waste management problem, we're talking about a fundamental design and business model problem when it comes to the levels of waste that we as humans are creating.
Thank you very much, Helen. And Alireza, like the technologies that you develop is like towards finding a solution to a part of this problem, right? Would you like to talk about them a little bit more in detail?
Definitely. So there are some serious limitations towards developing such technologies. And the first one is lack of a standard in designing such products. So we have diversity in design of these products. What does that mean? Means that we need to actually do kind of reverse engineering, understanding actually the components within these complex products, and then based on that, designing and developing actually suitable solutions. And also there is lack of data and information from OEMs, from the manufacturers, in order to understand better such complex products. So we are talking about, specifically about my area is about developing technologies for EV battery disassembly. And we are talking about hazardous scenario. When we are talking about EV battery, typically we are talking about 480 volts, and touching such batteries is quite a tedious task and requires proper handling systems, proper solutions, automated solutions, in order to understand at what stage these batteries are at end of life, and then accordingly we can provide a solution. So developing autonomous solutions is quite difficult. However, because of diversity in design, we have to come up with AI power or AI enable solutions that can basically cope with such diversity. So I will give an example how safety of these batteries are important. Imagine actually one of these EV batteries catching fire on the road. Just firefighters will leave the car if they catch fire for 1 or 2 days because they cannot handle the heat runaway. And after 2 days, just they are coming actually and collecting these batteries. And if there is any critical material left there, they will send it to the salvage center. And finally, we will have shredded material, or we call it black mass. But the question is around the purity and the quality of this black mass through traditional recycling or direct recycling. That's why actually always reuse of such components has priority than putting them on the shredders and make black mass, because actually the purity of materials will be degraded, especially I'm talking about lithium ion. And it's very difficult actually to use these materials after shredding for retrieving and making new EV batteries.
Thank you. Really seems like enormous challenges for a robotic system. Indeed, like all that diversity you're talking about in the OEM side. And thank you very much for the insights. We have Anwar, last panelist. Sorry, Anwar, I didn't see you in our panel list earlier. Could you please introduce yourself? So let me actually, Anwar, you might be muted. I will try to come back to you again very, very soon. Actually, Ellen, you are a pioneer in robot ethics. You were doing it before it was this cool, and we can say that. And the frameworks that you develop, they are actually about responsible design elements. When we see the problems that both Alireza and Manuel was talking about, and the perspective that Helen put in, like the broader perspective about the e-waste, what is going wrong in terms of the responsible design elements?
Yeah, that's a very good question. I mean, so one of the things that I've become very involved in over the past, let me think, 15 years is standards. So I was part of the team that developed a standard for the British Standards Institute called BS 8611. And it's basically a method for doing ethical risk assessment. And in fact, what I'll do is I'll put some links in the chat, because I've co-written with colleagues a number of papers where we've done ethical risk assessment of robots, physical robots, and we consider the
co-host now.
The problem of repair and reuse. So in other words, it's one of the ethical risks which exists for any piece of machinery. That's not just robots, of course. And in fact, you might be interested that there is also another standard, British standard, under development. In fact, it's currently just waiting to be restarted. But we've started to write a new standard on robots' sustainability. So the sustainability of robots and robotic systems. And I think that I'm really hoping that it gets onto the books, because it will be the world's first standard on sustainable robotics. It's called BS 8622, I think. Yes. So I'm a bit of a standards guy, really. I've also worked on standards for the IEEE, ethical standards, that is.
Wonderful, thank you. Also, some of your work is focusing on government regulations,
Sure.
right?
Yeah.
So could there be a role here, for example, when we talk about the challenges that in the EV recycling process, the diversity over there?
Exactly.
How can government play a role in those kind of situations?
Well, fundamentally, and I think that's a really great question. Fundamentally, standards have no legal binding at all. So they're kind of quasi-legal documents, but in fact they have no legal standing. So in order for a standard to be required, there needs to be regulation where the regulation says you cannot build this building, for instance, without using these particular standards. So standards, are everywhere. They're what I call a kind of invisible infrastructure of the modern world, without which, we wouldn't be talking to each other, using Wi-Fi and Zoom and all of that stuff. All depend on standards. So we need regulation, and we also need regulators. And I think one of the things that's very encouraging is that in Europe we have the AI Act, which is a really good piece of regulation, and it's now coming into law. And I'm kind of pleased as well that the UK Parliament currently has a kind of UK version of the European Union AI Act going through Parliament right now. We certainly have a regulator already in the UK that would be responsible. We call it the Health and Safety Executive in the UK. And of course, most countries have the equivalent regulator. So standards are important, but they, in order to have teeth, you need regulation and regulators.
Thank you so much. And I would like to turn to Manuel here. Actually, Manuel, maybe you noticed that in the previous panel, people already started talking about a part of your research in terms of like clothes that are not even worn once are getting disposed. And being a big part of the recycling. So when problem, I suppose at that point. What are the challenges in that domain? It really seems like one of those really difficult domains that for robotics to enter, because we are barely good at maybe manipulating flexible material, I would say. But can we learn about your expertise, learn about your perspectives here?
So basically, let's start from here. Handling deformable material is a complex task, even for people, even for humans, because when you have to handle things that don't have a perfect form and you have to dismantle, it is a challenge even for humans. Today there is the needs to handle this kind of material, because in textile and clothes that we produce million tons per year of trash, and there is the need to manipulate and to separate this material, because most of the material that we can recycle, only a little bit of the part of the material can be recycled. The rest is burned basically today. And this depends a lot on how is made the material, but also, if we think on our clothes, the presence of buttons, on zippers, or different kind of structures that are inside. So move that to automatic and robotic actions that are capable to handle this big amount of things is a very complex system. Today, a very complex problem. Today, we are looking for technologies that can mix the capability of the AI, that for sure is giving us tools to model this material, to understand the behavior of this material, but also to understand the peculiarity of this material. And from the other side, the robotics and the work that we did also as a European community in the last 20, 30 years is enabling the way to handle also such kind of stuff. It's still an open research problem, but the solution that are coming are really promising. Also, indeed, for example, in the Flex Cycle project, we merged the expertise for different field of engineering, but also from different companies that work on both sides. Production side, we work with a brand that produce clothes, and with the sites that handle this kind of recycling. And only, I think, merging the 2 point of view, as we are discussing now, the way on how we engineers product and the way on how we can think, how we can dismantle them, but also technologies that can be capable to handle these things is the only way to solve this big problem, basically.
So when you get a pile of clothes, like how are they getting, like how difficult is this for a robotic system? What I mean is, are they really, I assume that you get piles of clothes that the robots should be able to identify each one of them, considering this as from the technical point of view. But are there, for example, any type of standards, like are they at least clean, or do you need to, like, at least in the countries that you work in, are there some standards that help you develop your solutions, or do you need to navigate all these challenges from the robotics perspective? Because it does look quite challenging.
Yes, we can look at the problem from 2 points of view, at least. One is the amount of clothes and trash that we produce, that we have in our house and we dismantle during the years. All this material goes in places where it is collected and after moved to places where it's treated. But there are no standard, no regulation on that. So what you receive in these places where there is the handling is something that can be in every kind of situation. Okay. And so this is pose a lot of challenges in terms of situation of the material, cleaning of the material, cleanness of the material itself. From the other side, there is also another interesting point of view, at least in my experience, that is also the amount of clothes and materials that are produced by vendors, but that are not sold. These things comes back to the companies, and part of them are resold with a lower price, but part staying in their warehouse. So there is also this aspect that is really interesting. So you have a material that is not sold, that you can, for example, dismount and reuse in different way, or that you have to treat as a trash. One of the first aspects when you handle this kind of pathways is that you have to sort. So you have everything mixed. So the first challenge is to sort the different material, because this is important for the material per se, because you have natural textile, you have artificial textile, so you have to separate, because treatment for the different materials are different. And after you have to separate and handle to dismount in some way. Things on jeans or clothes, you have to separate components inside. So the total flow is composed by different phases. The first is separation. The second is handling. But this problem is also similar to other kind of flexible material, like cables. Cables is another big challenge that It's quite similar. The interesting point in tables is that there are machines that are capable to separate, for example, the internal material with the plastic that cover. But the situation where you collect all this cable, you have a big amount of a big mass of all these cables that you cannot directly insert in these machines that are very efficient. So again, you have to treat something that is a huge bunch of material, separate, handle in a way that is manageable by this specific machine. So are two different topics, two different fields of flexible material, but that share some challenges.
Thank you so much, Manuel.
You're welcome.
Keep up to doing hard work. It really sounds very, very challenging. We have Anwar joining us. I think the technical problems have been solved. Anwar, would you like to introduce yourself, talk about your
Can you hear me now?
solutions and problem? Yeah, we can. Please go ahead.
Perfect. It was also for me a hard work to get the Zoom get running it since we are not using Zoom so much. Sorry for it. Yeah, I'm Anwar Al Assadi. I'm since now almost 8 years at Fraunhofer IPA, and I'm leading a research group which is focusing on robot programming with focus on disassembly and assembly. It's a pleasure to join this discussion panel. For that, we are working actually specifically on robot programming, but since we are tackling the same challenges as I heard previously with non-standardization, etc., we are now, since I would say 1.5 years, working also to improve the product designs, because we are tackling sometimes quite challenging situations where we have to do and spend a lot of time on engineering special tools and effectors, etc., to enable a robot to disassemble that. While if you are starting in the previous process before the product came to the market and improve the design or enable some gripping points, etc., standard joinings, it could be a better way to enable cheaper automation for the last, let's say, point in a big chain where you are treating it at the moment. And I mean, it's the same point as Manuel also said. We have to one point, we have to sort it out. We have to have a running logistics chain, which enables one standard, let's say, product which arrives at a specific place or a specific machine, and that's a bit still tricky. Yeah, that's the quick intro.
Thank you so much. So, how close are we? You have been working on this topic, as you said, for a while now, in an institute that is famous in, making hard tasks possible, like hard applications possible. How close are we?
We are very close, since nowadays we can also combine a lot of product informations which are available, I mean, for the OEMs. But the tricky point is that the moment is to get them accessible per law or something like that. You can combine nowadays a lot of informations about the assembly process, for example, to reverse it, to know at one point, okay, that was glued. So there is an instruction for the assembly where a glue is applied, so that can be helpful at the end of the chain when you start to disassemble it. I mean, large language models, vision language models, we can combine these methods which are nowadays available, which enables us to get these quite of high effort which we had in the past for engineering this robot skill sequencing to enable that or to accelerate it. I mean, we are very, very close nowadays. We are capable to disassemble small electrical applicants. However, compared to the first projects which we had here in our institute on battery disassembly, that got very, very fast nowadays, how we can get machines running because of these toolings which we have nowadays for sequencing, etc.
Thank you so much, Anwar. And I would like to turn to Alireza. Alireza, you were saying like achieving the full autonomous system has challenges, but are there would there be certain like human robot partnership possible to get to the level that we want in a quicker way? Are you looking into exploring those kind of strategies as well? Or do you see the benefit of having the full autonomous system and shooting for that goal?
That's a good question. So the way that we are tackling this challenge of disassembly is that we are classifying the tasks in three different levels. Some of the tasks can be done in a fully autonomous way. It means that, for example, we have the CAD models for the number of different screws, nuts, and bolts. It means that actually with respect to the grippers or the tools that we are using, we should be able to some extent autonomously doing unbolting. But for some of the tasks, like, for example, removing the small battery components or modules or cells or cutting cables, which is a quite sensitive task that could cause fire or explosion, we need to have human in the loop, which is in some extent actually aligned with the strategies that we have, like Industry 5.0 or 4.0, designing human-centric approaches. And in that sense, yes, we are using actually telerobotics mostly for enabling the user. Very similar scenario when we are basically handling the nuclear waste material. We want to have safety, and also we want to complete the task successfully. In that sense, we are using telerobotics, sometimes integrated with mixed reality, in order to enhance the capability of the user during performing the tasks. And some of the tasks are quite difficult at this point that I'm talking to you, because mainly because of lack of standards and also diversity in design. In these cases, human should basically get involved and complete the tasks. One of the main tasks during this complex product disassembly is cutting. We have demonstrated in low TRL, because of the nature of academia, actually, as pilot study, how we can develop AI power or AI enable robotic cutting systems. But in reality, if we want to transfer it to industry in order to have a framework that can work for a number of different products, for a number of different complex products, it's a big claim to say that we are at this stage in the robotics community. I'm talking to claim that we are at this stage that we can autonomously perform all the tasks, because it's a very challenging scenario, and still actually we can see that the new products coming with the new designs, new materials, new type of batteries, etc. So we are moving towards that point, but I think that at this stage, to a large extent, we need to have human in the loop.
Thank you so much. And I guess then the design metrics, like design strategies, change quite a bit, isn't it? Like once you consider it as an option versus going for fully autonomous. And I guess many of these solutions require very urgent realization, very urgent applications, because I can imagine that these batteries are now piling already. Thank you so much for your insights. I would like to turn to Helen. Helen, we actually started with the framework that you provided us. And here again, maybe this will be a general question, maybe like tying the conversations, but also offering new perspectives as well. How can we solve the challenges of circular economy? I know this is a very I mean, okay, you have 30 seconds. No, it's it is the biggest question here, perhaps. But
Yeah.
Yeah, please go ahead.
I think that it will always be a combination of steps that we will take. There is not one solution. There is, as I mentioned, the responsibility at the design phase. So 80% of a product's environmental impact is decided during the design phase. So whether that is we push companies into making better decisions or create environments that make it worthwhile to them. So push-pull factors for the circular economy are a really interesting area, and it's something that we can read about how we manage our content in our lives. We have so much around us. So I do not think there'll be one method to change it. So one example is obviously the introduction of right to repair. And that was a conversation that was started as a community-led movement. And you did get some changes by companies just by having this movement, because it encouraged people to buy from places where phones that could be repaired, but they tended to be more expensive. So there's not necessarily everyone who can make that choice. So then you start to see regulations coming in places in the EU, in Australia, in the US as well. That's going to start forcing. But what's really interesting is if you actually start looking at the number of products that are under that right to repair legislation. So you create legislation and then you have to list what's included. And even then, there's always going to be loopholes. There's always going to be new products that come out. So I think there's a number of factors that come into this. So yeah, whether it's right to repair, whether it's providing businesses incentives to say that if you make your product more repairable, there'll be tax reductions or whatever it is. It needs to be a mix of that push-pull factor for both the businesses creating and the consumers. But we really need to remember that the consumers are the last point in that defense line of circular economy, and that it starts with the designers.
So it is basically a call for the companies as well to, like, struggling, for example, in certain technologies. Maybe we are talking about a consortium here, indeed, like having governmental, like the regulators to understand these problems in depth that the technologists are facing, and therefore put certain regulations to the producers. Is that kind of like
I think we have to be aware that sometimes the circular economy options or principles that we might want to apply will cost a business more. And if you genuinely want to make changes, you have to make other things easier. If you're going to force regulation, you also have to create concessions in other areas. And I think until we see that, probably even national, global, whatever viewpoint it is, it needs to understand that they are businesses. We are choosing as people to consume a lot in our world. And while we choose to consume, even if we want to make responsible decisions, it can be hard. Now, obviously, there are businesses who are doing better and worse, and we can learn from them. There is some level of regulation needed, because we will always, if you think of your iPhones, they used to have different charging cables. Changes in regulations, we now have universal charging cables. That is a force, but there is an opportunity. That's why I say with new industries like robotics, we have a chance to be ahead of that. Why would we wait to be forced when we can make changes now? But I also recognize, having worked in business and in industry, that it's expensive, and that will therefore require some balance of understanding in how we bring that in.
Yeah, and sometimes the consumers get the burden, like find the burden on themselves rather than maybe the producers, isn't it? In terms of costs and other means. Thank you so much. This was very enlightening. I would like to actually start for the closing session. We will have a round of hot takes. This can be some provocative point that you would like to make, and someone that would stay with the audience, and that they would remember either about the challenges that you are facing in your domain, or the solutions that you are producing. or anything that you like. Let's start with Manuel.
So working on these topics, and when I am at home, the hot point is also on myself, basically. All the cables that I have, all the things that I buy, how change the way when you see where these things goes. And when you start to think on that stuff, you start to think differently also on what you're doing in your daily life. I think that also the things start from us in this sense. I know that is a very generic, but really, I think it impressed me, this everything that I have at my home, and after I see where it is treated, where it goes, and how difficult it is to reuse. And I think that this is the hot point, really, also.
Thank you so much. Anwar, you are muted.
Sorry, I can just only confirm what Manuel say. Think about your consumer, but on the other side, I can only say to especially recycling companies. I don't know if we have some stakeholders from this community. You should trust what's going on in R&D and co regarding automated disassembly. There are very impressive achievements which have been done, especially in context of electrical vehicles, of battery disassembly. There, you can transfer it very good to other R paths, like remanufacturing of vehicle components, remanufacturing of aerospace, etc. So keep this domain transfer to enable to get it running in productive usage.
Thank you so much, Anwar. Alireza?
So the question was about the key points. Am I right, Berk?
Yes, you can. What is the hot take from this session for you?
Yeah, so basically, very a good combination of insights we received from the panelists. I know that actually this is a serious challenge at the moment that somehow should be addressed. But as Alan mentioned, I think that the first step is making standards and regulations around how we can basically perform recycling or handling these waste material. And also, there should be a platform where everyone can get benefit from the developments and achievements that they are making in this area. At the moment, there are a number of RTOs, there are a number of universities, institutions, etc., that they are all working to address one of the challenges in this about this topic, how they can handle this waste material, how we can increase the efficiency in recycling, etc. But to what extent actually they are sharing the achievements with each other, that's the question. And I think that actually we should move towards first having the standard and regulations globally around waste material. And the second one, actually, there should be a sharing point, sharing platform, actually, that they can work with each other in a larger scale, that enabling academia and research institutes enabling them to transfer the knowledge to industry and towards commercialization.
Thank you so much, Alireza. Really great points. And I would like to, so Ellen, actually you received a question. Sorry for reducing your time for your hot take, but that says, Ellen, could you please provide some examples of some of the ethical challenges with robotics hardware and environmental sustainability? Is some of this robotics waste also being dumped in Global South, like we have seen happening with things like computers, etc.?
Yeah, I mean I mean, of course, you know, this exporting of waste is appalling. It should be illegal, in my view. And you asked for a hot take. My hot take is that ethics needs to get political. And what does that mean? Well, I give a lot of public engagement talks with ordinary people, and they get very worked up when I tell them about all of the problems, the sustainability of AI, and so on. So I say, look, write to your MP, write to your parliamentarian. That's how to get political. If everyone who worries about what we're talking about now were to write to their local parliamentarian, then governments would start to listen.
Thank you so much. Thank you so much. Indeed, the trade part of it is like, I think that it's something that we will look back and say, how was this even legal, right? It will be one of those things. Thank you so much, Helen. So Helen, I see that you are actually started typing an answer to one of your questions. Please continue doing that right after we receive your hot take. But also you also have I think a question that you can address as well. The other question, which is, how is recycling industry financed? Does it have to be enforced by law that users / producers have to spend money on recycling? Will there be a point when some resources will be so scarce that it will be economically viable? So is there any economic incentive, or is it basically mostly sticks, or are there carrots? Can you also provide a very quick answer to that?
Yeah, and I can only speak for the UK and for what the extent of my knowledge, which was only certain types of products as well. Generally, in the UK, it's financed. So the recycling is targets put on councils for us. So this is local areas in which we live, and they're done by targets, and they are required to recycle a certain amount of material. Not necessarily how well they recycle it, but really about what they pick up from homes. And I do not think that's necessarily the way to go. So that does not involve businesses at all. It does not involve the producers of products paying into the recycling of that product. So if you are a company who makes something that can only be recycled, it cannot be reused or repurposed, there is no requirement on you to finance the recycling or the avoidance of that item to landfill. As far, I'm sure there may be other countries, I cannot speak to those. I think there was within that it says it's economically more because our resources are finite, and I do think that is a point, but we are collections of vast numbers of businesses and governments, and it is a really challenging question for this wider group, and that kind of brings me to my kind of really the hot take. It links a bit to Alan and a talk that I went to. It talked about engineers as a silent profession, where we think our product speaks for us, but actually we need to start speaking for our product and taking responsibility for it across its life cycle. People are fundamentally the center of this. It links to the other question as well. Do we buy because we want to consume, or do we buy because that is the economy that we're part of? So I find one of the things that I find really interesting is our mobile phones. So we often choose to keep them once they're dead. We also describe them as dead rather than broken a lot of the time, because we have this emotional connection with them. And that's partly why we won't get rid of them. They cost us money and we are emotionally connected to them. And so we can't get rid of them. And that's a really interesting concept. So how do we apply that feeling of value to more things in our lives? Because then we won't look to throw them away. Then we won't look to send them to landfill or to recycling. And that's more an ethical and a moral question for us as a society, but impacts how we manage our waste across the world.
Thank you so much. And I think this is a great point to end. Thank you so much for our panelists, for all the great insights that you have shared in many different perspectives, many different areas, domains. I hope everyone enjoyed it as much as I did, because I did a lot. And see you all tomorrow in the Climate Robotics Summit Day 3. See you, folks. Thank you.